Hello chemistry fans, and welcome your faces back to Chemistry 1032 problem solving session. I am your host, Dr. Russell Betts, here at the Academic Success Center on Broward College North Campus, and I'll be guiding you through this problem today. So let's just jump into it. Alright, Chapter 7, Problem 7. For the following reactions, identify which reactant is being oxidized and which is being reduced. Very common question. One that gives students a lot of trouble. So let's think carefully about what we're doing. So we want to know what's being oxidized and what's being reduced. And hopefully you know, Leo the lion says GR. Leo, L-E-O, lose electrons, oxidize. So if something is losing electrons, it is oxidizing. Leo the lion says GR. GR, gain electrons, reduction. So with that in mind, let's just kind of jot down Leo GR here. Lose electrons, oxidize, gain electrons, reduction. Okay, so here, sodium on the left-hand side is sodium metal. So sodium with zero charge. You can put a little zero here if you like to remind yourself the sodium is neutral. All the protons equal the electrons in number. And going to now, over here, of course, the entire reaction is giving us sodium chloride, but the sodium in sodium chloride is sodium plus, and chloride, of course, is chloride minus. So the sodium is going from being neutral, no charge on the left, to being a cation on the right. Now, atoms, cannot lose or gain protons. They can only lose or gain electrons. So the sodium, going from left to right, is losing an electron. In order to become positive, you must give away or somehow lose an electron. Leo the lion says GR, lose electrons, oxidation. So it's oxidized. So the sodium is being oxidized. Now, if you have an oxidation, you must by definition have a reduction. Electrons can't just fly off into space normally. There's ways to do that, of course, but not normally. So in this case, the sodium is being oxidized, the chlorine must be reduced. But let's prove that to ourselves. Now you could balance these equations and do mass balancing. In my class, I don't particularly care about that so much, unless it's a mass balancing question. In this question, I'm very concerned is can you figure out who's gaining and who's losing the electrons? That's what I care about. So some of your professors out there may want you to mass balance this and then show how many electrons are being transferred from left to right. But in Chemistry 1032, at least as far as I'm concerned, I'm not overly concerned that you can figure that out. But I am concerned that you can figure out what's being oxidized and what's being reduced. Okay, so from here, chlorine becomes chloride. So chlorine has no charge. Chloride has a -1. So in order for chlorine to gain a negative charge, it must have gained electrons, or it was reduced. All right? So that's how that one is done. Now I think these are pretty straightforward. I think it's just a matter of conceptualizing in your head how this works. All right, so we have magnesium becoming magnesium cation. So magnesium on the left, no charge. There's nothing written here for a charge, so that must be magnesium metal becomes magnesium plus 2. Now how did I figure that out? From here, the formula. Magnesium nitride, Mg plus 2. Magnesium is a group 2 metal, so magnesium as a cation can only ever be plus 2. Nitride is -3. Nitride is always -3. Nitrogen is 0 charge, no charge at all. Nitride is -3. So the magnesium goes from being magnesium with no charge to magnesium with a plus 2 charge. So this is a loss of electrons or an oxidation. Oxidized. All right? Nitrogen becomes nitride. Now again, if your professor would want you to mass balance this in these kinds of questions, please go ahead and do so. I'm not concerned with that. I am concerned with starting with nitrogen 0, becoming nitrogen minus 3, can you figure out, is it gaining or losing electrons? And if you're going from being no charge to being a -3 charge, you must have gained electrons or reduced. All right. Now, this last question is a little bit different look. This is an organic question. Here we have a carbon-based molecule reacting with oxygen. Leo the Lion says Gur is true. It's true here. It's true everywhere. But in these types of questions, it's a little bit more convenient to think of oxidation in a different light. You can also think of oxidation as the gain of oxygen. These two questions didn't involve oxygen, so we couldn't think of it that way. But down here, we have oxygen. So if you would notice, the carbon from here goes to the right and becomes CO2. The hydrogens are, first of all, the hydrogens are all gone, and the carbon has attached 2 oxygens to itself. So going from left to right, the carbon has gained oxygen. So oxidation is also the gain of oxygen. So carbon is oxidized. It's oxidized because it's gained oxygen. Carbon here has no oxygen. Carbon over here has 2. It's gained oxygen. Okay? Now here, the oxygen, O2, has been reduced. Now how do I know that? Because reduction is the loss of oxygen. Notice here, the oxygen is bonded to itself. If you wanted to, you could draw the Lewis structure like this. So the oxygen is bonded to itself here, and in CO2, let me draw CO2 right here. The oxygen has now lost itself, if you want to think of it that way. This oxygen was bonded to that one. Now this oxygen is bonded to the carbon, and this oxygen is bonded to the carbon. So each oxygen, in a matter of speaking, has lost an oxygen. So this oxygen is no longer bonded to that one. They're both bonded to the carbon. Okay, so that's oxidation reduction for carbon-based molecules or biologically based things. All right, now I hope this has been a very helpful video to you, and I hope you've been able to figure these out. Now, if you haven't, or you're still having difficulties with these kind of problems, please contact one of the tutors here at the Academic Success Center and have them help guide you through this problem. And if you'd rather, come on by and see your professor during normal office hours. And with that, I'd like to wish you good luck and good chemistry.